I'm Sarita Kumari, Assistant Professor in EEE Department, working in Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Today, I'm going to give the introduction in the course Electrical Power Transmission Systems. So, first, I'm going to show the course outcome related to that. So, the course outcome is given. Compute the line parameters of a single phase and three phase transmission lines using the concepts of GMR and GMB. So, as this is the introduction part, so it mainly talks about the transmission line, basic transmission line parameters and its related terms. They are geometric mean radius and geometric mean distance. So this is the first module 1 syllabus. So the module 1 syllabus, which is mainly concentrated on the transmission line parameters. So well, so under that we start with the uh, what are the conductors, various conductors they use in the transmission lines, and then the calculating resistance, uh, then calculating inductance, and calculating inductance for single phase line as well as three phase line. Okay, using the concepts associated with that GMR and GMD, and then problems based on that, and then uh, third parameter capacitance calculation for the transmission line for a single phase transmission line and a three phase transmission line. So this is all about the module 1. So which are the transmission line parameters: resistance, inductance and capacitance. So these are the textbooks we can refer for the according to the syllabus. The first book we can say CL Wadhwa, Electrical Power Systems. Book name, title, Electrical Power Systems. Author is CL Wadhwa. Years publications, New Delhi, 2007. And then the other second book, third book, fourth book also mentioned. So we can refer those books also, but first book is a good book which I can strongly prefer for this course. So first, before going into the module 1 discussion, a small introduction about the power system. So if we see the structure of a power system, as we can see on the slide, so the structure of power system, mainly it is divided into four categories, we can say. So first one is on the left side, on the slide left side you can see, so generating system, then after that transmission system, and then after the transmission there is a distribution system, and before distribution there is a sub-transmission system also there. So in this structure of power system, okay, the areas or categories are, that means how the power is generated, produced, okay, from the power plant, and finally how it is delivered to the consumer premises. Okay, so that's why that is what the mainly the structure means: generation of the power. Okay, that generated power is transmitted over the overhead transmission lines, okay, over long distances, that is called transmission systems. And then that transmission lines, the power through them, the power is given to the substations, where that is given to different consumers, using that is distributed to various consumers. that may be industrial consumer or a domestic consumer. So that is called distribution system that happens from the substation. So these are the three a categories, three areas, and the fourth one is in this structure. There is a utilization. How the the utilization of the power. So these are the four things involved in the structure of power system. So if we see once here, first here on the generating the generation, from the power plant, the power plant may be a thermal power plant, or nowadays we have the non-conventional power sources like solar, wind. So anyway, from those power plants, power is generated, okay, which is usually rated at 11 kV or 33 kV. Now, this power generated power to finally reach the consumer premises, that must be transmitted over long distances. So, here what they do is to transmit that power, the generated voltage is stepped up to higher voltages for the transmission purpose to reduce the power losses. So, that is stepped up to 132 kV, 220 kV, or 440 kV. So then that high rated voltage is transmitted over the transmission lines. These are the transmission lines. Okay. So these are the transmission lines which are placed on the supporting towers like this. So this is transmitted. Then from there it is it goes to sub-transmission system where the voltage is a little bit step down using a step down transformer, that is step down to 66 kV. So then that sub-transmitted power is finally reach the distribution station, that is actually we call it as a substation, where the voltage, okay, is reduced, step down to the requirements of the consumer. The consumer, if the consumer is a industrial consumer, then that is stepped down to 11 kV. Okay. If it is the consumer is a domestic consumer, a house requires a single phase AC or a three phase AC. If it is single phase AC, that is stepped down to 230 volt using a step down transformers like this we can see in the figure. So this is how the power is transmitted and distributed from the generating station to reach the consumer premises. So this is a structure. Next, the power sector divisions. Okay, the power sector divisions state wise. Okay, if we take a Telangana state or Andhra Pradesh, okay, let's see here. I have the on the slide Andhra Pradesh. Okay, the same divisions are also there in the Telangana. So here there are four divisions in the power sector. So there are usually we know that the power sector, which is managed by the government. So this power sector, the government have the four divisions. They are regulation, generation, transmission, distribution. Okay, so first about the regulation. Under regulation power sector, the government has it is named as Andhra Pradesh Electricity Regulatory Commission. So that is that takes care of the power uh, power management. Okay, so that means power in and power out. How much power is coming? How much power is going out? So those kind of things. Example, I can say. Next generation. So that is managed by the for AP Genco, Andhra Pradesh Power Generation Corporation Limited. Okay. Similarly, in Telangana State we have TS Genco, Telangana State Generation Corporation Limited. So next, transmission also in a similar manner. Okay, Transmission Corporation of Andhra Pradesh Limited, AP Transco. Okay, then under distribution, we have the two areas: Eastern Power Distribution Company Limited and Southern Power Distribution Company Limited, EPDCL, SPDCL. So this is what the power sector divisions a state usually have to maintain the power. Okay, to maintain the power in the state. So Indian national grid scenario. Indian national grid scenario. So see that this grid management, the grid, it is there. Okay, so here basically it is there. Okay, on the regional basis started in 1960s. Okay, so grid means national. Okay, it is a common point. Okay, for the whole nation. Okay, under electrical power we have a common operating voltage and frequency. Okay, as one nation. So that is called national grid. So in our India we have Indian national grid. So here the first point is telling that is started on the regional basis. Okay, in 1960s, and initially state grids were there. Okay, and they are interconnected to form this regional grid. State grids are interconnected to form the regional grid. And then look at the next point. India was divided into five regions, namely northern, eastern, western, northeastern, and southern region. So these are the five regions. You can look it on the right side. In the map, we have the northern region, okay, and then eastern region on the far right side, northeastern region, and on the left side western region, then down south region, okay, southern region. So these are the five regions we have. Okay. And initially in 1991 October, northeastern region and eastern region were interconnected. So first these two regions were interconnected in 1991. Then in 2003 March, Western region and NERER, the first one. Now these were interconnected. Next, that is what they did. They interconnected those two. Then in 2006, North and East grids were interconnected. Thereby, four regional grids, Northern, Eastern, Western, and Northeastern grids, are synchronously connected, forming central grid operating at one frequency. So that's what happened in 2006. Then on 31st December 2013, Southern region was connected to the central grid. So that is in 2013. So southern region connected to central grid in synchronous mode. Okay, with 765 kV Raichur Solapur transmission line, thereby achieving one nation, one grid, one frequency. So as I already mentioned, grid means it is a uh, operating point. Okay, power system operating point operating at constant voltage and constant frequency. So that means one voltage, one frequency. So that is what finally we have one nation, one grid, one frequency. So in India, our operating frequency is 50 hertz. Okay, anywhere in the India, any state. Okay, 50 hertz. And voltage also the same. For single phase AC, 230 volt. For three phase AC, 415 or 440 volt. Okay. Next, I talk about the conductors. What are the various conductors they use in the transmission lines? The type, the overhead conductors. Okay, it is here. It is mentioned. Overhead conductors means the conductors used in the overhead transmission lines. So here, conductor is a physical medium to carry electrical energy from one place to other. So basically, the transmission line, as we have seen in the previous slide in the structure of power system, the transmission lines are placed on the supporting towers, right? So what are those transmission lines? Those are the conductors. Okay, so here they use conductors to transfer the electrical energy, to carry the electrical energy from one point to another point, or one place to another place. Okay, so next, a good conductor should have the following properties. Whatever the conductor they use in the transmission lines, it must have the few properties. First one is, it must have high electrical conductivity. That is the first thing. Then second point, high tensile strength in order to withstand mechanical stresses. Okay, high tensile strength it must have. And then lower weight for unit volume. Lower weight for unit volume. Okay, and relatively lower cost without compromising much of other properties. So uh, properties a good conductor should have: high conductivity, electrical conductivity, high tensile strength. Okay, high tensile strength to withstand the mechanical stresses, and a lower weight. Okay, for unit volume, and last one, it should have lower cost. Okay. So what are the conductor materials they use in the transmission lines? Generally, they use copper, then aluminum, and also afterwards other materials and alloys. What are those? What are those other materials and alloys? Silver, galvanized steel, copper, cadmium, phosphor, bronze, etc. Now, what are the types of conductors they use in the transmission line? Yes, we know what are the various conductor materials. Okay, they prefer to use. Now, what are those? Okay, uh, in specific they are using. Here we can see. So first one is AAC, all aluminum conductor. Next, AAC, okay, triple AC, all aluminum alloy conductor. And then ACSR, aluminum conductor steel reinforced. And ACAR, fourth one, aluminum conductor alloy reinforced. And then fifth one, bundled conductors, and generally, okay, bundled conductors. Okay, so and then what they are telling is, generally all these conductors are in standard form in order to increase the flexibility. Okay, that means instead of using a solid wire, simply, okay, they use a standard conductor. That is what they are telling. Now, we can see in the next slide how is a standard conductor looks like. So on the left side we can see this is a standard conductor. This is a standard conductor. Standard conductor. So where this is nothing but standard conductor means it is made up of number of small wires, number of small wires wrapped together to form a large conductor. Okay, that is called standard conductor. number of small wires wound together to form a large conductor. Okay, so now here, what is a you can see bundled conductor, that is standard conductor. Fine. Then what is this bundled conductor? Okay, so bundled conductor means it is a conductor, okay, having two or more number of subconductors. Okay, that is called bundled conductor. Okay, a conductor having two or more number of subconductors, it is called bundled conductor. Whereas standard conductor means it is made up of number of small wires. Okay, wound together. So now, what is the difference between a standard conductor and bundled conductor? So usually a bundled conductor, the distance between the subconductors is usually 30 centimeters or more. The distance between the subconductors, okay, is given 30 centimeters or more. But in standard conductor, the subconductors they touch each other. The subconductors they touch each other. So that is a standard conductor, which is also sometimes they call it as a composite conductor. Composite conductor. Okay. So that is a standard conductor. Now, example, a copper wire 7 by a copper wire 7 by 30, 7 by 30 wire. Okay, if that is mentioned like this means a copper 7 a copper wire, okay, with 7 by 30, okay, they mention, let us say, then that means what, it has seven number of inner strands, okay, seven number of inner strands, which each having value of 30 gauge. Okay, each wire having seven number of wires are there, and each wire having the gauge 30. So that is the meaning of the this one 7 by 30 wire means. Now, coming to here once again, what is this aluminum conductor steel reinforced? Okay, and what is this the next one? Okay, aluminum conductor steel reinforced means it is having, okay, it is having the outer strands made up of aluminum outer strands. Okay, outer strands. Next slide we have that, right? Have a standard conductor, there are number of strands. Okay, inner and outside, right? So these are the inner strands, and these are outer strands. So ACSR means aluminum conductor, right? So aluminum conductor, right? Steel reinforced. So means here the outer strands are aluminum. The outer strands are aluminum, and the inner strands are steel. Okay. So, and this aluminum having very good high conducting property. Okay, and lower cost. Okay, lower cost. Whereas steel, okay, the inner strands, which is usually which provides a good support, good support to the weight of the conductor. The steel provides support to the weight of the whole conductor. So that is a ACSR conductor. Okay. So next, ACAR. So that is means what? Aluminum conductor alloy conductor. Alloy is reinforced. Sorry. Okay. So means outer strands are aluminum. Okay. The outer strands are aluminum, and inner strands are alloy. They are made up of LY. That is the meaning of the ACA. So this is about the standard conductor. Okay. So and bundled conductor. Okay, standard conductor and bundled conductor. So and here we have seen the on the left side this is a standard conductor, and here on the right side we can see this is a we can say bundled conductor. This is a bundled conductor. On the first picture, the two conductors are bundled together. And the continuation next figure, three conductors are bundled together. And the next figure, four conductors are bundled together. So this is an example, okay, how the bundled conductors, okay, and also how the standard conductors are. So this is about the conductors, generally all about the conductors which they use in the overhead transmission lines. Overhead transmission lines for the transmission of the electrical power. Okay, that's all for this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.